Okay, welcome to the final presentation of the day. So I'll be talking about materials control accounting technology. So my name is Mike Rhyme, and I'm the program manager for this account. And I'll talk a little bit about our program to give some background information, and then I will discuss the call. But I guess first and foremost, we're looking for some innovative, creative ideas in the area of safeguards, materials control, and accounting. We're trying to focus on hardware this year, probably detector, or maybe maybe a system of detectors, as opposed to the last couple of years where we funded modeling for molten salt safeguards. So what is the Impact program all about? Our vision is a competitive fleet of advanced reactors and fuel cycle facilities, and that meet current and future nuclear material control and accounting requirements. So it's kind of a lofty goal, but we're here to support the future of the nuclear industry, and we're here to account for nuclear material. To do that, we plan to enable the next generation of nuclear materials management and advanced fuel cycles. More specifically, MPAC focuses on domestic fuel cycle activities. So there are other offices in NNSA and other places that fund international and IAEA work more directly. But we're really focused on the U.S. Nuclear facility, or the U.S. nuclear industry, rather. And finally, I guess I'll just say that some of the industry concepts for advanced fuel cycles have unique safeguards and security needs that are different and more challenging than the current fleet and the current storage and disposal ideas. And I'll talk a little bit about that shortly. So how do we accomplish our mission? Primarily, first and foremost, we develop innovative technologies, analysis tools, and integration methods. So we're talking detectors. Currently, we're funding a number of detectors, including gamma spec, neutron spec, a number of salt monitoring technology for pyroprocessing. So to accomplish our strategy, we essentially demonstrate these technologies in real world facilities where possible. So the Idaho National Laboratory has a number of places where we can test, especially some of the molten salt items. We've also done round robins with gamma and neutron spec, trying to collect samples from the complex and analyze actual real world samples. So it's sort of a mishmash of detector technologies as well as analysis tools, and finally coming up with unique ways to integrate the data from multiple sources. So taking detector outputs and taking safeguards and security models and doing a systems engineering approach of allowing that data to work with each other to give you what you need to know about nuclear material accountancy. So that's the primary strategy, what I would call technology development. But we also coordinate and engage with stakeholders early on. There's been a lot of interest in safeguards and security by design, both within the US and through the IAEA. Just sort of as a concept, the NRC has also been, I don't know what the right word is, they've been pursuing that concept as well. And certainly with the advent of the roughly dozen advanced reactor companies or designs that are ongoing right now, we're getting a little bit of interest from industry as well to start thinking about safeguards very early in the design process. So where do we focus? This chart has much more information than is obvious on this slide, and I should have had some interesting moving arrows to show you. But if you look at the entire fuel cycle, you need safeguards and security, you need nuclear material accountancy throughout the entire thing. However, the next sub-bullet on this chart, if you look at the light gray shaded boxes, those are things that the Office of Nuclear Energy as a whole is currently focused on. Not to say they haven't focused on other areas in the past, but to me, these seem to be the priorities in NE at large. For impact, however, I've narrowed it down a little bit further into the 3 green boxes. So we're really looking at NEUP projects that focus on advanced recycle, like especially the advanced reactor fuel recycle box under recycle, but also ways to safeguard advanced reactors. I do have interest in safeguarding molten salt reactors, which really has a lot of overlap with advanced reactor fuel recycle. If you're adding material into an advanced reactor, or if you're reprocessing online or in an adjacent facility, those two technologies are very similar. And well, they have similar safeguards and security needs, or similar nuclear material accountancy needs. So to me, those are the areas I'm most interested in because they pose a unique challenge, and I'll talk a little bit about that. However, I really want to, this is a pretty wide open proposal, for better or for worse, and I am looking for creative ideas for safeguards and security at large, though I will focus on the 3 green boxes on this chart. So what are these challenges that I mentioned? At sort of a high level, you can imagine traditional nuclear material accountancy includes, counting items, looking at especially LWR concepts. It's a lot of tagging, visual inspection, things like that. However, advanced reactors and processing facilities, they have safeguards challenges that are not fully addressed by existing approaches. So you have things like you could use a normal instrument, or you could have a perfectly fine instrument, but can it operate in high heat or high radiation environments? Can it operate in a facility where lots of material is moving around, like in a pyroprocessing facility? Or if you have liquid fuel or coolant, are there technologies that could better safeguard that material because you can't simply count fuel pins, things like that. In addition, there are a lot of new potential signatures in advanced fuel cycles. You have new product and waste streams, and there might be novel, unique ways to combine data to get to the nuclear accountancy needs you may have. So it's kind of a challenge and an opportunity, but essentially advanced fuel cycles are an interesting problem, and that's where we're looking for creative ideas. In order to make measurements for advanced reactors and processing facilities, we need a number of technology, a number of ideas, a number of analysis tools, a number of ways to bring that together to solve the problem. So in terms of metrics, I mean, we're talking improving your measurements, lowering your uncertainty, improving the timeliness, or novel ways to keep costs down. One thing about the safeguards world is that the nuclear industry is already challenged economically, so we really can't be a burden on a facility's operations. So we have to keep that in mind. So any ideas that can accomplish any or all of those things are more than welcome for this call. We're also looking for potentially expanding the scope to include more indicators than the traditional ones, or combining indicators in these facilities in a novel way to generate new data. So it's really sort of all of the above, but can't stress this enough. We're looking for unique, novel, creative ideas. So the proposal itself, I've sort of summarized it, but I'll read it, I suppose. Proposals are requested to develop innovative materials control and accounting technologies and tools for molten salt related nuclear energy applications. Asterisk, it can be broader as shown on my previous slide, but I am interested in molten salt primarily because molten salt reactors and advanced reactor recycling facilities for molten salt are 2 very interesting and challenging safeguards needs. Finally, technology, we're also looking for technologies and tools to increase the accuracy, reliability, efficiency of nuclear materials quantification and/or tracking capability. So again, this is fairly broad, but we're looking for some creative stuff here. This could include quantification, well, this must include quantification of actinides or combinations of indicators that could be required for nuclear material accountancy. And again, to repeat this for the 3rd or 4th time, we're looking for ideas that are in challenging environments from the fuel cycle to include molten salt reactors or processing facilities. One other note, which is always good to point out, it's very helpful and arguably necessary for the universities submitting ideas to partner with the national labs. So we have a strong tie-in to program needs. We've had some really good relationships in the past where the research was tied very closely to impact researchers at the national labs, and they really came up with some great results. So just want to give a plug for that as being a high priority for these proposals. And finally, I think it's worth pointing out, compared to last year, we have changed the duration and funding levels for the call. So we're looking at 2 years and up to $400,000. Both of these are reduced a little bit, and I think that should give us a little bit more flexibility to fund some smaller projects that are, you know, more diverse. I think it'll give us an opportunity to pick a few things, whereas in the past we're a little bit limited. So I think most of that made sense. But yeah, that's the end of my presentation. I welcome any questions that you might have.
Thanks, Mike. We will take questions over the next few minutes, so please submit those in the GoToWebinar app. Mike, where does this FC3 scope divert from the RC1 scope, which is on MSR materials? In other words, what are the differences between the two, and how many proposals would you support?
So my understanding of that, of the other area, that is more focused on basic material research, like understanding salt chemistry. I don't have it in front of me, but I'm fairly certain that is the primary concern in that area. There could be some overlap, but from Impact's point of view, we're really looking at focus on technology for addressing safeguards needs. So essentially accounting for actinides in the salt. Although there are different ways you can get there with not necessarily direct measurement. There are indirect ways you could also reach that. So I would say that they're different in the sense that one is materials and chemistry research versus impact, which is safeguards focused, but there could be some potential overlap.
What TRL levels are you interested in?
So let's see, that's a good question. I have, in the past, the program has not explicitly defined the TRLs we're looking for, but I believe we usually look between, like on the low end, it's around 3 to 4, up to, if I remember correctly, around 7, I think. So essentially a pretty big swath of stuff in the middle. I would consider accepting slightly lower TRL projects for this proposal because I think it's really important to get some fundamental research done that is creative and unique that could fund the next generation of safeguards technology. So I would say don't limit yourself too much, but that's my wishy-washy answer to that question.
Would novel applications / algorithmic enhancements of existing impact supported instruments, e.g. the high dose neutron detector, be considered sufficiently novel? And the distinction they're looking for here is incremental improvements versus improvements of existing tools to extract new information.
Right. That's a tough one. Who asked that question, if you don't mind?
Well, we can tell you afterwards.
Okay. That's a tough question. I don't want to, if you think you have a good idea, I think you should submit a proposal. That said, if I had to choose between something that is, I don't know, the word new is not quite the right idea. If I had to choose between an idea that was new to me and I thought had potential versus an incremental improvement over something Impact has funded for a number of years, I would probably lean towards a newer proposal.
Where modeling and simulation could play a role in the program, what national labs will be appropriate partners in a proposal?
So a lot of our modeling and simulation work is done with Argonne or Sandia. And currently, Argonne 10 has modeled some of the physical facility layouts and some of the batch process modeling to support a notional pyroprocessing facility model. Sandia has a lot of expertise in safeguards and security modeling. So those would be two good places to start. But Oak Ridge also has a lot of experience modeling as well, especially for molten salt related items. So you have a lot of good options there.
Mike, I'll answer the next one. The question is, will there be opportunities for greater funding in the future for successful proposals? And the answer to this question for all of the FOA areas is that each application for each fiscal year is a separate, distinct application. This program, the NEUP, NEAT, NSUF programs do not typically do follow-on funding. Everything here is competitively funded on a year-to-year basis. So there are programs that do follow-on scopes based on results that they receive from projects, but they are always competitive in nature in the CINR. We'll keep the line open for about another 30 seconds before we let Mike go. So please do submit any questions you have.
Yeah, these are really good questions, and more interest, or a few more than last year, which is good.
Mike, can you please clarify if modeling and simulation is not a focus of this year's call?
So I would, similar to my earlier answer, which is not going to give you a real immediate yes or no, I would prefer that this call focus on hardware and detector design, or materials to support material development to support detector design. However, I think we may have the flexibility to fund a novel idea in modeling and simulation as well. So those are my thoughts.
Mike, there's a question about the number of proposals that you anticipate on funding in the area.
I don't have an exact answer, but I think we can, I'm thinking between 1 and 3, probably. It's a little bit in flux because it has to balance with the other proposals in my office, is usually what happens. There's a little bit of bartering that goes on. But if we have 3 very strong proposals at 400K, we can probably make that happen, is my feeling. So don't want to overpromise that, but I think so.
There is some interest in potential non-proliferation and safeguard applications of remote reactor monitoring. Is this topic considered relevant to the call?
It's a good question. So I feel like I've seen some of these proposed for NE20 work. I have to admit, it isn't directly on my radar as being something I'm explicitly looking for. That said, if it applies to advanced reactors that are similar to or could be similar to those that the US industry is building, I would say you should absolutely submit a proposal.
Okay, Mike, it looks like those are all the questions we have for you. Thank you for being here. This concludes the second day of the FY 2020 CINR webinar. Please do tune in tomorrow starting at 11 a.m. Eastern time. We'll have several important topics, including the NEAMS program, the integrated energy systems program, as well as TRISO fuels and advanced SMRs. So we'll see you tomorrow. Thank you.